Welcome to this tutorial on the best practices for working with tuples in the Zig programming language. Tuples are a powerful feature that allows you to group related data into a single data structure. Today, we'll dive deep into their characteristics, usage, and some best practices to consider while working with them. So far, we learned about advanced struct and memory management in the Zig programming language, emphasizing its performance and safety features. We covered topics such as field access, packed structs, and the critical importance of proper memory allocation and alignment. The lessons highlighted techniques to handle dynamic memory safely and emphasized the role of error handling to maintain data integrity. As we wrap up, we prepare to shift our focus to concurrency and task management in the next lesson. Now we'll talk about tuples and how to use them effectively in your Zig programs. Tuples can be seen as a list of values that can be of different types, making them quite flexible. Their structure is similar to that of arrays, but with a significant difference. Tuples can hold a mix of different data types, while arrays are limited to elements of the same type. Now let's see how we can implement a basic example of a tuple in Zig. In this code, we start by importing the standard library and defining the main function. We create a tuple containing 4 different types of values: a 32-bit unsigned integer, a double precision float, a boolean, and a string. This demonstrates tuples' capability to hold mixed data types, showcasing their versatility. Next, we access each element of the tuple using its index. The index for accessing tuple elements must be known at compile time, which ensures type safety and allows the compiler to perform checks. We then assign each value to a corresponding constant variable number, decimal, boolean, and text. Finally, we utilize the std debug print function to output these values in a formatted string. This highlights how easily we can print multiple data types from a single tuple, effectively managing diverse data in a simple structure. This example not only illustrates how to define and access a tuple, but also emphasizes the practical advantages of using tuples for organizing related data in your programs. Now let's see how to leverage the len property of tuples in a practical implementation. In the code, we begin by defining a tuple named myTuple containing 5 integer values. This illustrates the versatility of tuples to hold multiple elements of the same type. Next, we access the length of the tuple using the len property and print it to the console. This feature is particularly useful, as it enables us to understand the tuple's size before we begin iterating through its elements. Following this, we utilize a for loop to iterate over each item in the tuple. The for loop structure allows us to not only access each element but also its corresponding index, enhancing our ability to manage the data effectively. Within the loop, we print each value along with its index, showcasing a clean and efficient method for processing tuple data. This approach not only emphasizes the ease of tuple manipulation in Zig, but also exemplifies how tuples can streamline code while promoting clarity and functionality in handling collections of data. Now let's see how we can implement the ability to concatenate tuples and work with duplicates using the + and asterisk operators. In this example, we start by defining 2 tuples. First tuple, which contains the integers 1, 2, and 3, and second tuple, consisting of 4 and 5. By utilizing the ++ operator, we create a new tuple called combine tuple that merges the elements of both first tuple and second tuple. Furthermore, the asterisk operator allows us to duplicate the elements of second tuple, effectively repeating it twice within our new tuple. The result is a combined tuple that contains all elements from first tuple followed by 2 instances of second tuple, showcasing the flexibility of tuples. We can easily access the length of this resulting tuple using the len property, which provides an efficient means to understand its size. Additionally, we loop through combined tuple, printing each value alongside its index, which reinforces the tuple's ability to provide indexed access similar to arrays. This example effectively demonstrates how tuples in Zig can be leveraged for dynamic data manipulation. Next, we will write a function to demonstrate tuple destructuring in Zig. The function divmod takes 2 parameters, numerator and denominator, and returns a tuple containing the results of division and modulus operations. This design leverages Zig's ability to return multiple values through tuples, enhancing usability when functions are intended to yield more than one output. In the main function, we are going to see how destructuring can streamline our code. We call divmod with values 10 and 3, and by using destructuring, we unpack the return tuple directly into the variables div and mod. This means we can immediately use these values without the need for additional indexing, which can enhance readability and reduce potential errors. Moreover, with the exception handling via the catch keyword, We ensure that any issues during the division or modulus calculations are appropriately managed, displaying an error message without crashing the program. Finally, we print the results, showcasing both the quotient and remainder. This whole process exemplifies efficient code structuring when dealing with functions that require multiple return values. As we dive deeper into the best practices for tuples, it is essential to consider how to handle the possible errors that arise from operations involving them. Zig emphasizes safety, so proper error handling becomes critical when manipulating tuples. Utilizing error handling via the catch keyword helps manage situations in which tuple access might return an invalid outcome. In our previous destructuring example, we added exception handling to catch any potential errors from divmod, thus maintaining the integrity of our program. As you're embracing tuples in your coding journey, remember that tuples aren't always the best choice for every scenario. While they are extremely versatile for grouping related data, if you find yourself using tuples where the size and type of elements vary greatly or where you're frequently modifying contents, consider whether structs or arrays might be better suited for the job. For example, if you need to store user information such as a name and age, a struct might provide clearer field definitions, while tuples might suffice for quick data packing in smaller scopes. It's also crucial to understand that tuples in Zig are immutable by default. This means that once you've defined a tuple, you cannot change its values. This immutability feature aligns with Zig's goals for safety and performance, enabling the compiler more freedom to optimize. If future modifications might be necessary, consider whether the usage of a different data structure, such as a mutable array or struct, fits better. By determining where immutability makes sense, you maintain both integrity and efficiency in your code. In conclusion, tuples in Zig provide an excellent way to group different types of data into a singular manageable structure. We covered their key features such as indexing, len access, and the powerful ++ and asterisk operators. Through examples, we demonstrated how to efficiently destructure tuples and handle potential errors properly. Keep in mind when tuples are the right choice versus other constructs, and embrace their immutability as a means to enhance your program's safety. In our next lesson, we will pivot toward concurrency and task management, an exciting frontier in programming that opens up possibilities for creating responsive and efficient applications. Thank you for joining this exploration into tuples, and I look forward to our next session.